Good morning. Hope you're feeling okay. I have been informed that you are suffering from Froziety. Since this disease is rare and many people don't know much about it, I am here to provide you with the information to help you put it all into perspective and calm your nerves. So let's begin with talking about the parts that make up the muscle. Muscles are supplied with blood vessels, nerves, and connective tissues which involve the epimysium, paramysium, and endomysium. There are 3 different types of proteins engulfed in the muscle: contractile proteins, which involve myosin and actin; regulatory proteins, which are troponin and tropomyosin; and structural proteins. So how do all of these work together to make our muscles contract? Well, calcium ions are released from the sarcoplasmic reticulum and bind to the troponin. Because the troponin is not holding tropomyosin in place, the tropomyosin moves, exposing the active site on the actin. Myosin then attaches to the actin. After this, ADP and P are released and the myosin head moves towards the center of the sarcomere. Then, the myosin lets go of the actin when the myosin head binds to another ATP. When the ATP is split into ADP plus P, the myosin head is reactivated and the myosin head moves and is ready to attach to actin again. As a result of this, the muscle fiber shortens and the filaments slide past each other, making our muscles contract.
Action potential introduced at the neuromuscular junction is propagated along the sarcolemma of the skeletal muscle. At the T-tubule, the action potential is propagated on the T-tubule membrane into the interior of the muscle cell near the ends of the sarcoplasmic reticulum. The depolarization of the T-tubule membrane causes nearby voltage-gated calcium ion channels on the sarcoplasmic reticulum to open, resulting in an increase in the permeability of the sarcoplasmic reticulum to calcium ions. Calcium ions then diffuse from the sarcoplasmic reticulum into the sarcoplasm. Long filamentous tropomyosin proteins lie on 2 sides of the actin myofilament, covering up the sites where myosin can bind to the actin myofilament. Globular troponin proteins are attached to the tropomyosin. When calcium ions bind to troponin, this causes troponin to change conformation and move the tropomyosin. When the tropomyosin moves, this uncovers the myosin-binding sites on the actin, allowing myosin heads to bind and form cross bridges. The cross bridges play a role in muscle contraction.
Now you're probably wondering what Froziety does to the normal routine of a muscle contraction to make it not so normal. Let's take a look. So the troponin is on in Froziety. That's good. But oh no, the tropomyosin won't move. It appears to be frozen. If the tropomyosin doesn't react and blocks the way of the myosin, then the myosin head has no place to go and can't attach to the actin. In order for the myosin to find the active site, the tropomyosin has to be released. If the myosin can't get to the actin, then the muscle can't contract.
No flex zone! No flex zone!
So let's talk about what you've learned here today. We've learned how a muscle contracts normally, and then how a muscle contracts that has Froziety. We saw this through the actual scientific terms, and then through the video. We hope that you have a better understanding now on what Froziety is. It's up to you now. Don't let this silly disease stop you. Go out and make the best of what you've got. I believe in you, they believe in you, we all believe in you. Good luck.
Okay, bye.